has access to technologies and opportunities
Krishna ma'am, your voice is breaking because of some network issue. Our secretary sir has also joined. Sri Sailesh Gogoli sir has
Okay,
joined the meeting. Your voice is
okay.
breaking, so that will you please?
Is it better now?
Probably if you switch off your video mode, then probably it will be audible.
Is it better now? Is it better now? Sir, is it better
Sir, is
now?
it audible? Yeah, it's okay.
Yeah,
Sir, secretary sir has joined.
yeah.
Secretary
Okay.
sir.
Pandiji, just a minute.
Uh,
Very good afternoon to all of you, and thank you so much to Amrita Vidyapitham for this support to the state government, and we are very happy that you are taking the session here. And I'm sure our the principals and the faculty members that are present here, they'll be able to learn quite a lot about virtual lab and how we can take it forward in our state. Our state is, as you understand, it's mostly hilly region. The colleges are in far-flung areas of the state, uh, uh, where actually it is very difficult considering the bandwidth, the financial bandwidth available with us. It is very difficult to set up the actual labs in many places. But since going forward, since technology has been driving, kindly pay their attention. And I would again request, as Pandeyji had requested, to kindly keep uh, your uh, your screen in switch off mode or mute mode, so that we are able to listen to what ma'am is telling us. सबसे मेरा निवेदन है कि अपना जो इसको म्यूट में रखें, अपना जो स्क्रीन है उसको, ताकि हम लोग सुन सकें अच्छे से. या मैम, यू कैन कंटिन्यू प्लीज. सॉरी.
Okay. No problem. Is everybody able to hear me, understand? Yes. Okay. So I thank you very much, sir, for that introduction. I think we are equally excited and equally fortunate to be able to work with the state of Uttarakhand. This work is actually a passion of lot of love and effort from Amrita Vidyapitham, and our earnest desire is that it will reach every student in the country. I was just talking a little bit about the history. About 11 institutes in the country developed these virtual labs, and it was really done with the intent of invoking the interest and the understanding and learning from laboratory practices. Obviously, we cannot build experiments that demonstrate every single scientific phenomenon in the lab, and it has always been that labs were part of curriculum without really invoking a student to think through the application part of the lab. So here what we have done is, how can we really bring several experiments in a joint way on a single platform to be able to offer that for students to be able to do experiments that they cannot even typically do those through virtual laboratories, so that they can actually think about what happens when parameters change outside of their, say, Earth-like environment. So if you want to change the gravity of Earth environment, how will this experiment change and what will be the result? Things like these are what we feel will invoke further interest in students. So we have tried to design those experiments that way. One of the things I also wanted to say as a Civil 20 national coordinator for technology, security and transparency group is that this is a perfect example of technology empowerment that we have done for teachers and students across the country, and this is highly applicable across the world. We have many examples of students who are not only from India but across the world using these virtual labs on a day-to-day basis, and we think that this will be equally useful for not only doing your current curriculum but also interacting with us to see what we can actually empower the teachers and the principals for future educational needs. With that, I really thank the host institute and the state government to really have given us the opportunity, and have my colleague and my associate, Mr. Sanish, take over the presentation of virtual labs.
Thank you so much, ma'am. We believe that your facilities will surely benefited our student and teacher as well. And we are very thankful to your organization and your all members to provide such facility to our Department of Higher Education Uttarakhand. Thank you so much, ma'am.
I have one request. I would love to come in person sometime and also
Yeah,
interact with all of you.
yeah, that's sure, ma'am. As per the Secretary said direction, after that online workshop, we will surely invite you for the offline workshop that will probably happen in Dehradun and in Doon University. So whenever we will plan this, we will invite you and your full team, ma'am. And apart from that, we are also welcoming you in any occasion. If you want to come, you may come, ma'am. Thank you so much.
Thank you
इसी
so much.
इसी कड़ी में अब मैं आगे इस वर्चुअल लैब वर्कशॉप के वेलकम एड्रेस के लिए ही हमारे माननीय निदेशक महोदय को आमंत्रित करना चाहूंगा कि वो अपने आशीर्वचनों से इस कार्यशाला को आगे बढ़वाने की कृपा करें। निदेशक महोदय।
परम सम्माननीय इस कार्यक्रम की अध्यक्षता कर रहे हैं हमारे माननीय मुख्य अतिथि शैलेश गोगोली जी, सेक्रेटरी सर, शांत आर्य जी, अपर सचिव साहब और एक्सपर्ट के रूप में उपस्थित अमृता विश्वविद्यालय से कृष्णा मूर्ति अच्युतम मैम एंड इस कार्यक्रम के हमारे नोडल ऑफिसर डॉक्टर चमन कुमार जी, डॉक्टर दीपक पांडे जी and all principals and faculty members participating from the college. It's really our privilege to have been taking this initiative by Higher Education Department that this virtual lab initiative has been taken by the government of Uttarakhand in order to strengthen our libraries, our laboratories. And this initiative has been done previously in 4 colleges, Lohaghat, Rudrapur, Uttarkasi and Dalpathar. But presently we are having such university who has great experience in operating these digital virtual labs. And these virtual labs are necessary because they can provide better teaching, better learning, and state-of-the-art research, and also the incubation and innovation, as well as the creativity and entrepreneurship. And after all, it will enhance the quality of life. So this is very student-centric, and therefore this is the need of the hour to extend these facilities, especially in the hilly region of that this state-of-the-art technology can be available to all the colleges for their for the betterment of their quality of education. So I welcome you all in this orientation camp, and I hope that you will listen our experts and also implement the virtual lab program in your colleges so that students at large can be benefited. Once again, I welcome our chief guest, Shailesh Gogali sir, and Prashant Arya ji, who has taken a lot of initiatives in digitizing the higher education system, and a lot of initiative has already been taken, and this is one of this initiative. Thank you very much.
धन्यवाद सर, आपके आशीर्वचनों से हमारे पूर्ण विभाग में इस तरह के कार्यक्रम निरंतर आयोजित किए जा रहे हैं और एनईपी को लेते हुए ही काफी नई योजनाएं भी प्रारंभ की जा रही हैं। धन्यवाद सर। सर, इसी कड़ी में अब मैं आमंत्रित करना चाहूंगा जिनके निर्देशों और जिनके पूर्ण सहयोग से ये नई सुविधाएं हमारे विभाग को निरंतर उपलब्ध होती ही जा रही हैं, हमारे अपर सचिव श्री प्रशांत आर्य जी, जिनके निर्देशों में ही ये कार्यक्रम भी आहूत किया जा रहा है। अपर सचिव महोदय, प्लीज ज्वाइन सर।
थैंक यू चमन। बहुत बहुत धन्यवाद निदेशक महोदय का। सभी का स्वागत है, सभी प्राचार्यगण, एंड अ वेरी गुड आफ्टरनून टू वर्चुअल अमृता विश्वविद्यापीठम। मैं से कंफ्यूज हो जाते बोलने में। मैम, वेरी नाइस टू हियर यू, थैंक यू सो मच। सभी प्राचार्य गणों से मेरा अनुरोध यही है कि वर्चुअल लैब या लैब दोनों तरह का फैसिलिटी को हायर एजुकेशन में हम किस तरह से इम्प्लीमेंट कर पाते हैं और बच्चे कैसे इसका लाभ अधिक से अधिक ले पाते हैं, वही अभी हमारे सामने एक मिशन है, टारगेट है। और इस टारगेट को एनईपी के गाइडलाइंस में अब मैंडेटरी हो गया। हम जो चाहते थे वो गवर्नमेंट कहीं ना कहीं चाहती है कि हो, तो दोनों चीजें पॉजिटिव है। व्हाट वी वर सपोज टू डू नाउ इट्स अ पार्ट ऑफ पॉलिसी। तो वर्चुअल हो या चाहे फिजिकल हो, हमें उस माध्यम से बच्चों को रूबरू कराना है, नया टेक्नोलॉजी, नया चीजों के प्रति जागरूक भी करना है, और ये एक इट्स अ स्टेप फॉरवर्ड। तो जैसे सचिव सर का भी निर्देश था, डायरेक्टर साहब का मंतव्य है, और हम सब चाहते हैं कि इसको हम और बेहतर तरीके से जोड़ पाए बच्चों के साथ। तो उसी का एक कड़ी है कि वर्चुअल लैब में हम लोग जुड़ रहे हैं एक सबसे बड़े संस्थान के साथ जो पैन इंडिया सर्विस अवेलेबल करा पा रहा है। तो मुझे बहुत आशा है और कि आप लोगों के सहयोग से हम बच्चों को ये एक बेहतर सुविधा, अब YouTube के शॉर्ट्स देखें या Facebook इंस्टाग्राम के शॉर्ट देखें, वो भी वर्चुअल हैं। जब आप उसमें एंजॉय कर सकते हैं बच्चे, तो ये एक ज्ञान बढ़ाने वाली चीज को अवश्य एंजॉय करेंगे, क्योंकि ये नॉलेज है वर्चुअल वर्ल्ड में। और बाकी चीजें जो बच्चे देखते हैं, हम भी देखते हैं, वो कहीं ना कहीं नॉलेज से कनेक्टेड नहीं है, वो इंटरटेनमेंट से कनेक्टेड है। इससे तो एक अलग तरह का डायमेंशन बच्चों के सामने खुलेगा और हमारे सामने भी खुलेगा। तो इन्हीं संभावनाओं के साथ शुभकामनाएं आप सभी प्राचार्यगणों को। आपके माध्यम से ये नेक काम होगा, तो आपको मेरी ओर से साधुवाद और बहुत बहुत धन्यवाद। थैंक यू डायरेक्टर साहब।
लेकिन फर्स्ट ईयर के हो जाएंगे आप, फर्स्ट सेमेस्टर सेकंड सेमेस्टर उनके तो
धन्यवाद सर। इस इनॉग्रल सेशन के समापन सत्र पे हम आ ही गए हैं। इसके बाद टेक्निकल सेशन स्टार्ट होंगे, जहां पर अमृता विश्वविद्यापीठम की टीम वर्चुअल लैब को किस तरह से प्रयोग किया जाना है, किस तरह से इस पर आप लोग इस सुविधा को प्रयोग कर सकते हैं, लॉगिन कर सकते हैं, उससे संबंधित जानकारी दी जाएगी। लेकिन उससे पहले एक बार मैं पुनः आप लोगों को अवगत कराना चाहता हूं कि समस्त महाविद्यालयों में ई लर्निंग समिति गठित की जा रही है, जिसमें समिति में सभी संकाय के प्राध्यापकों या सदस्यों को जोड़ने हेतु निर्देशित भी किया गया था। उसका उद्देश्य ये था कि इसमें एलएमएस और वर्चुअल लैब, इन दोनों ही कार्यों को ई लर्निंग समिति द्वारा संपादित किया जाएगा। एनईजीडी जो नेशनल ई गवर्नेंस डिवीजन है भारत सरकार का, उसके द्वारा हमारे विभाग को एलएमएस सुविधा भी प्राप्त होगी, जिसके लिए जल्द ही एक उसके लिए भी कार्यशाला आयोजित की जाएगी। लेकिन उससे पहले हमारे प्राध्यापकों और विद्यार्थियों के इसको आप लोगों को द्वारा प्रेषित किया जाना है। तो जिन महाविद्यालयों से वो ई लर्निंग समिति की इंफॉर्मेशन अभी तक नहीं आई है, उनसे मेरा निवेदन रहेगा कि वो शीघ्र ही उस ई लर्निंग समिति की इंफॉर्मेशन digi.heuk@gmail.com पर प्रेषित कर दें। उसके उपरांत ही आप लोग ये वर्चुअल लैब सुविधा तथा एलएमएस सुविधा प्रयोग कर पाएंगे। अब इस कार्यक्रम के समापन हेतु, इनॉग्रल कार्यक्रम के समापन हेतु मैं धन्यवाद ज्ञापित करने हेतु हमारे सहायक निदेशक प्रोफेसर दीपक पांडे सर को आमंत्रित करना चाहूंगा कि वो आमंत्रित सदस्यों को धन्यवाद ज्ञापित करें।
थैंक यू चमन। बिना किसी औपचारिकता के, चूंकि ये कार्यक्रम हम सभी का है, और हम सभी एक ही परिवार के सदस्य हैं, तो सभी को बहुत बहुत धन्यवाद कि आपने अपना अमूल्य समय दिया, विशेष रूप से अमृता विश्वविद्यापीठम और उनकी पूरी फैकल्टी को कि आप हमारे साथ एक हमारे हायर एजुकेशन के जो साइंस फैकल्टी के जो स्टूडेंट्स हैं और टीचर्स हैं, उनको ट्रेनिंग के लिए आप हमारे बीच हैं. तो आई वुड लाइक टू एक्सटेंड आवर Vidyapitham, and without any delay, as per the instruction of Secretary Sir, I would like to request to start the technical session. So thanks to all the respected principals, our director sir, our secretary sir, our additional secretary sir, everyone who is present in this virtual meeting. And I would like to request to Amrita Vidyapitham to start their technical sessions. So thanks to all.
कोई बोल रहा है, कुछ नहीं हुआ.
Am I audible, sir? Hello, am I audible?
Yes, audible.
Yes, sir.
Yes, sir.
देखिए, मैं दोबारा रिक्वेस्ट कर रहा हूँ, अभी भी कुछ लोगों के माइक खुले हुए हैं. कृपया अपने माइक म्यूट पे रखिए क्योंकि बहुत डिस्टरबेंस आ रहा है.
And the respected principals and head of the department and faculty members and all students, welcome to virtual lab online workshops and very good afternoon each one of you. And I'm also excited. So I kindly request you to mute your microphone, and in case if you are not, my audio is not audible, and if you face any difficulty to hear my presentation or audio, please let me know so I can repeat the session again. So with that, I'm just start sharing my screen. Okay, so I hope all of you can see the screen. So I'm just turning off my camera. Yeah. So are you able to see the screen, sir?
Sir, it is not presented yet, sir.
Okay, so if anybody is able to see the screen, please let me know.
No, sir.
Okay, sir.
Not yet.
Okay, okay, I'm just sharing it again. 1 second. Yeah. So are you able to see the screen now?
Yes, sir. Yes, sir. It is presented, sir.
All right. Thank you.
It is visible. Sir.
Right. So once again, welcome to Virtual Lab Online Orientation Program. So we call this project as Value Virtual Labs, which stands for Virtual Amrita Laboratories Universalizing Education. It is being funded by Ministry of Education, Government of India, under National Mission on Education through Information and Communication Technology. So before starting the session, I would like to introduce a little bit about our university. So this is our Chancellor, Mata Amritanandamayi Devi. She is the spiritual leader and all the guidance and success of our university. And Amrita is recognized as #1 private university as per THE World University Ranking. And also we recently accredited as NAC A++ grade. And also the National Institute of Ranking Framework, Amrita is recognized as 5th best university in India. Okay, so these are some of the ranking framework that we Amrita University got recently. So come back to our session. So is there something wrong, or is the present system of education is sufficient? So this is the basic thought behind the development of this beautiful platform called Virtual Lab. So I would like to go through some of the thought process. So the right hand side you can see the smartphone, and left hand side you can see the telephone, which is almost 100 years old. Okay. So similarly, if you are comparing with our automobile, the right bottom you can see the modern automobile, and left top you can see the automobile which is almost 100 years old. So you can see there are a lot of innovations and technology implemented all these automobiles, the smartphone, etc. But if you are comparing with our classroom scenario, you can see the right bottom, you can see the modern classroom, and left top, you can see the classroom which is almost 100 years old. So instead of blackboard, we are using grey board, whiteboard, and sometimes we are using projector, screen, etc. But the method of teaching is almost similar for all these years. So what is the drawback of this education system? Because each students have different capabilities. Some students have to visualize what they are learning. Some students have to perform or actually do the experiment or exercise to understand the concept behind the topic. And similarly, some students have to listen and some students have to read and write it in their book to understand the concept. So each students have different learning capabilities, but one faculty member may not be able to cater each student's needs separately. So that is one of the barrier in our traditional education system. So why we are keeping more important to the laboratory? Because students are learning theory from their classroom scenario, and what they have learned the theory, they are applying through these laboratory sessions, right? So they are learning a lot of skills, they are gaining a lot of skills, and they are understanding how to solve the problem in future also. Because in laboratory situation, students are provided with certain, as you can see, there are limited amount of resources and chemicals that will impact students on learning as well as laboratory experimentation. So these are already existing technology. The left top, you can see the pilot simulator. So the pilot will get training using this type of simulator before handling the actual aircraft. So his confidence level will drastically increase after performing this type of simulation. So similarly, the right top, you can see the remote control operation system, which is called Da Vinci. So the real operator is placing some other geographical location. He or she can perform the real-time operation using this type of technology. And similarly, the left top, you can see the driving simulator. So today's world, we are using this type of technology to provide driving tests as well as training in driving. And right bottom, you can see the augmented reality. So the medical students are mostly using this technology to see the three-dimensional view of the subject what they are learning. So there are a lot of technologies are already existing, but why we are not implementing any technologies in our education system? That is the basic thoughts for our development of this project. To solve this particular issues with laboratory education, Ministry of Education, and 11 Combined Institute come up with this idea called virtual lab. So these are the participating institutes. You can see the Amrita Vishwavidyapita, IIT Bombay, IIT Kanpur, IIT Delhi, IIT Kharagpur, IIT Roorkee, IIT Guwahati, IIT Hyderabad, the Alpha Education Institute, and National Institute of Technology Karnataka, and College of Engineering Pune. So all these institutes are participated for developing this beautiful platform, where Amrita is mainly focusing on physics, chemistry, biotechnology streams, and IITs and other institutes are focusing on engineering background, like civil, mechanical, computer science, etc. So the basic motivation behind this project is one is a physical distance and experimentation. So the students can perform their laboratory experiments only in the allotted time. So what will happen if students are not able to complete their experimentation? He or she has to repeat the same procedure on the next day. So the effort will be higher, and they need to put more time for performing the experimentation. So one is that is one of the drawback of barrier for our traditional system, and another one is the cost effective and hands-on experience. Because of the fact that several equipments are really costly, students are not currently allowed to play or perform those costly equipment-related experimentation in our laboratory setup. So students will lack of knowledge about the complete experimental procedure, and also that will impact their learning as well as motivation for learning the same subject. And third one is a sharing of costly equipment. So through this virtual lab Nodal Center program, we are providing a facility for the Nodal Center to visit any of our content institute, and they can visit the laboratory, specifically like costly equipment laboratory, and they can see how these experiments are typically performed in our laboratory setup. So I'm just combining into 4 points. One is to provide remote access to various labs, disciplines of science and engineering. Second, to provide better students at the UG level. PG level as well as to research scholar. And third point is to enable students to learn at their own speed. If you want to perform or want to know the experiments in mechanical or civil engineering laboratories, this platform provides a facility. They can actually see the apparatus and working principle as well as they can perform the experiments in the other disciplines as well. But in a traditional situation, students are not allowed to enter any other disciplines laboratory in the our curriculum, etc. Yeah. So basically, there are 4 types of labs we have. One is animation. So animation is just like a watching video. So when students are watching this kind of animations, they can easily memorize the step-by-step procedure they need to proceed in the traditional laboratory. So instead of reading a textbook or a paragraph, the students can easily memorize the step-by-step procedure that help them to effectively perform their traditional experimentation in the laboratory session. And second one is the interactive animation. So interactive animation is just like an animation, but some part of the animation students can interact with it using keyboard and mouse, then only it will continue. So that interactive animation will provide the basic or importance procedure that students have to take care in the traditional experimentation. And third one is the simulation type. So simulation is just a replica of our traditional laboratory setup where students can see the schematic representation of the laboratory setup and they can change the parameters of the experimentation and they will get the real-time data in the platform after changing the parameters. So one of the beauty of these simulations are like students can explore they can perform the experiments that are usually not possible with our traditional situation. For example, projectile motion or simple pendulum experiment. Students can perform those experiments on the surface of Moon, Saturn, Jupiter, or any other planet to perform the experiment. So, as I said, you can see the animation representation. So, the concept, all the apparatus and chemicals that students need to use in the experimentation. So, when the students placing the mouse pointer over each of the components or apparatus, it will pop up the name of the component or chemical that they are going to use the experimentation. So, that way students can understand what are the apparatus or chemicals they are going to use in their practical before going to the real practical scenario. So this is the screenshot of our simulations or simulation experimentation. So this is the EMF measurement lab, and the right hand side there is a control panel where students can change the parameters of the experimentation. So for this particular experiment, you can see the temperature, and there's a slide of remote to the lab. So right hand side you can see the live streaming of the apparatus, and students will get the real-time data as a graphical representation, and also they can export the data as CSV file. And using the data, they can analyze and find the objective of the experimentation. So a little bit about the development step of virtual lab. So initially we have conducted a survey all over India to identify what are the most common experiments that are used by most of the universities in India. So after getting the list of experiments, with the help of subject matter experts, we created the storyboard and all the content for this virtual laboratory. And with the help of software engineers and animators, we created the simulation animations or interactive animation. After that, the review committee will review each of the component, and once they approve, we will commit into our virtual lab server. So once we commit into the server, all the users can access the content via internet without using an internet. So there is no additional cost or anything for accessing this virtual lab platform. So these are the labs under biotechnology and biomedical engineering. So we have biosignal processing and analysis, bioinformatics, neurophysiology, biochemistry, etc. So my colleague Nichin is also joined this session. So she'll be explaining more about the biotechnology related experimentation. And these are the labs under chemical science. So we have physical chemistry virtual lab, organic chemistry, inorganic chemistry virtual lab, analytical chemistry. Similarly, we have physical science virtual labs also. So we have electricity and magnetism, heat and thermodynamics, harmonic motion and waves, modern physics, laser optics, mechanics and advanced mechanics lab, electric circuit, optics virtual lab, and solid state physics. And we have some mechanical engineering, wind energy, solar energy, etc. And we have one computer science lab, wireless sensors and network. So these labs are not limited to this particular what I have mentioned. There are a lot of labs, around 3,000 experiments are available in the virtual lab platform. So students, those who are interested, they can go and explore and they can perform the other labs as well. Okay. So this is the site homepage for Amrita Virtual Lab, vlab.amrita.edu. So today we will be exploring some of the experiments from this platform. So I request you to just note down this site address, vlab.amrita.edu. All right. So once you enter any of the experiment, at the top you can see the experiment name, and there are several tabs that we have arranged, starting from theory, procedure, self-evaluation, simulator, assignments, reference, and feedback, etc. So why we are keeping it as a separate tab? Because students have to follow each tab carefully in order to get the complete idea about the experimentation. So after going to the theory tab, they can refer the procedure tab, and there is a self-evaluation quizzes to test their basic knowledge about the particular experimentation. After that, there is a simulator is available. Okay. So I think that screen share is off. So are you able to see the screen?
Oh no.
Okay. So
Now,
yeah, I'm just sharing it again. Okay. So I hope you can see the screen now.
yeah.
All right. So this is the main website, elab.co.in. So you can note down the site address also, elab.co.in. From there, you can access all the labs developed by IITs and other partner institutes. So this is the launch of this virtual lab project on 23rd February 2012 by the Ministry Kapil Sibal at that time. So after launching this project, we provided this facility to all the institute and users in India for free of cost. It's true, one students are we face difficulties during this COVID time, but all the teachers are somehow managed to conduct online teaching or theoretical session. But students are very difficult to perform this laboratory experiment during the COVID time. So this virtual lab platform provided a beautiful opportunity for most of the institute all over India. So they utilize this platform and they provided this virtual lab to as a hands-on experience for performing the laboratory session. So these are some of the training or that we have provided recently. So we are providing as a 1 day or 2 day training for the effective utilization. Also that so we are studying the impact of the students community as well as in institute. We have 110 book chapters, 51 conference papers, 11 conference posters we have published. All the details are available in our university website. So we'll go through some of the papers if we have a time. So I would like to discuss some of the challenges in our laboratory. So just quickly go over this. So there are two types of challenges. One is psychological factors and physical factors. So I think all of you have understood that psychological factors like procedural complexity, fear of experimentation, visualization, conceptual understanding, retention. So because of there are a lot of procedures involved in the experimentation, students feel eager to perform some experiments in the additional laboratory, and also some students need what they are performing in their experimentation. Okay. And also conceptual understanding and retention. So students are learning this theory as well as performing some of the laboratory session, but they may not be able to retain what they have learned. So this is likely to forget what they have learned at the time of exam. So they need to recall it again. But this virtual lab somehow helps the students to retain what they have learned, and they can very effectively perform their final exams or practical exams, etc. And physical factors is very straightforward: time, distance, cost, shortage of resources, and laboratory hazard. So these are the typical physical challenges that we are facing in our traditional laboratory. So students will not have enough time to perform the experimentation, and also there are shortage of resources or chemical that will also impact the students to complete their experimentation.
उससे मेरा क्या फायदा, मुझे क्या मिल रहा है, मुझे क्या दे रहा है.
Okay. So in a nutshell, it is an on-demand lab. Students can learn at their own space, and it's a integrated learning. So all the contents are available in one place, and self-evaluation quizzes that the students can test their basic knowledge about the experimentation, and animation video tutorial that will provide a better insight about the experimentation, and also freedom to make mistakes. So in our traditional laboratory, we cannot afford to make mistakes that may damage the apparatus or it will maybe hazardous for the students or fragile materials, etc. But as it is a virtual lab, there is no fear of making mistakes in our virtual lab sessions. So as a social impact, we are sharing of lab resources. So we are connecting rural and remote colleges, and it's a paradigm shift in ICT-based learning, and it's a platform for exchange of knowledge, and it's a quality improvement in engineering education. So we called this virtual lab as a model laboratory textbooks where students can interact with it, and from there they can learn the basic concept behind the experimentation. So intention of this virtual lab project is not to replace our traditional laboratory, but to provide the concept behind the experimentation, and also very effectively they can utilize the traditional laboratory session. So with that, I'll just conclude with my presentation, and we have a short video about the project. Then we will continue with our experiment demonstration session. Alright, so I hope you can see the screen and just playing the video. So let me know if you are not able to hear the audio.
Virtual labs, broadening perspectives. Technology is radically transforming the learning landscape of modern education. Learning has traditionally been confined to brick and mortar classrooms. With the learning experience extending all beyond the walls increasingly more educational institutions
मेरे दोस्तों आईपीएल हो गए आईपीएल देखो भाई आईपीएल देख
and social networks. Amrita University is revolutionizing science and engineering education by pioneering a radical new educational tool, virtual labs. Virtual labs are immersive, knowledge, online learning environments that allow users to perform physical laboratory experiments in a computer simulated environment, anytime, anywhere. This innovative new educational tool is enabling scientific experimentation beyond the boundaries of traditional laboratories. Project background. The Virtual Labs project is funded by the National Mission of Education through ICT by the Ministry of Human Resource Development, Government of India, and is being developed in partnership with IITs and other prominent universities across India. Amrita University calls this project Value Virtual Labs, which stands for Virtual Amrita Laboratories Universalizing Education. This is an initiative dedicated to developing virtual labs in various science and engineering disciplines. Value Virtual Labs provide free and universal access to simulated, animated, and remote experiments to students. Under the National Mission on Education, over 150 laboratories are being built in various disciplines of engineering and sciences. Types of virtual labs. These digital learning tools are enabling students to practice and learn the theory and concepts behind the experiments in new and collaborative ways. Virtual simulations. Here, interactive equipment that can be operated in a virtual laboratory environment is provided. Animations or interactive animations, where students can view experimental procedures in detail. Trigger experiments. Here, Amrita engineered cutting-edge technology is used to help students to remote actual physical laboratory equipment and collect real-time data through the internet from anywhere in the world. Value Virtual Labs uses the most up-to-date subject content and web-based technologies to add a level of interactivity to college-level science courses. Based on the national model syllabi, teachers can easily integrate virtual labs into their classrooms. Through the use of detailed animations, mathematically accurate simulations, and a web browser, students are provided with near hands-on experiences on a large array of physics, chemistry, and biotechnology experiments, with virtual laboratories being developed for mechanical engineering and computer sciences. Specific features of virtual labs. In addition to simulated experiments, these virtual learning environments have a number of features, which include illustrated theory notes, animations, modeling, interactive quizzes, as also workbooks and video lectures that can be viewed as many times as necessary. Benefits for education and society. The vision of this project is to provide free and easy access to high quality educational resources to higher education students across India, regardless of whether they are based in geographically remote rural areas or economically challenged backgrounds. The free and open access feature of virtual labs allows sharing of scarce and costly scientific equipment with institutions. Test positive. This provides to conduct experiments that they would not otherwise have access to. Virtual labs technology helps bridge the gap between institutions that are able to maintain physical laboratory space and equipment and those economically challenged educational institutions that are not. Impact on institutions, nodal centers. Several nodal centers have been inaugurated and the creation of an additional 32 nodal centers is in progress. Each nodal center inauguration actively engages both students and faculty in demonstrations and hands-on learning of virtual labs. With the nationwide launch of virtual labs by the Government of India, students now have anytime, anywhere access to an encyclopedia of science and engineering knowledge presented in a way that is engaging, immersive, and enjoyable. The result will be a new generation of students that will have equal access to high quality education.
Is not coming.
These experiments and labs will be hosted for open access through the main project website at relab.co.in and at the university website at amrita.relab.co.in. With the help of nodal centers and the enthusiasm of the students, Value Virtual Labs are well positioned to help students explore and learn scientific concepts through the exciting and innovative world of virtual laboratories. So, try Virtual Labs today.
All right. So I hope that you understood some basics of what is virtual labs and how that can be used for the teaching and learning purpose. So now we are demonstrating the experiment from this virtual lab platform. So I kindly request all of you to watch how the friends can typically perform. They can perform using this platform. So I'm just sharing my screen again.
Some inquiries.
Yes, please.
My first inquiry is regarding if we are going for this virtual lab, then we must ensure the online evaluation also. Unless we have the online evaluation on the erstwhile simulated data, what the teacher or the faculty member of the concerned college may provide, the simulated data in order to correctly declare the precision and the error in the result, and the procedure will remain the same because the student has learned from the online, that is the virtual platform. He has to be examined. He cannot be examined offline, and that's why we should take these two things together.
Right, right, sir. So what I would like to suggest that these virtual labs are not to not to replace our traditional laboratory session. So using this virtual lab, we can provide.
I'm saying that suppose I have changed the concentration of some electrolytes in some experiments. Then we have put the experiment to the students for test, and they are going to declare that this is going to fetch this much result through the simulated experiment. All we need to know is the simulation part of the experiment, virtual lab. So whatever hands-on we are going to get, we have to be expert over this simulating experimental parts, isn't it?
Right. So using this virtual lab platform, there are so many possibilities that teachers can provide assignment for the students. For example, you can change the molarity of titulations in for different students. So students will get different answer for each of their experimentation. So those answer we can verify whether they have gone through
that's
this.
That's what I told you, because if we are enabling the student to learn from the online platform, then he has to be evaluated from that platform also. This will be judicious.
Yeah, so just like in our exams in that kind of situation, we can evaluate their performance or answer using a online questionnaire or any kind of questions to the students. So apart from our traditional laboratory, we cannot individually observe how students are performing. Rather, we can evaluate their performance based on their result or answer submission for the particular experimentation. So that's how we are typically evaluating our students in our university.
Suppose I am a chemistry teacher. I gave you my simulated data experiment for the result. What I am going to put up to my students. Then we can have the result simulation, or then we can go for it.
Yeah, so you are asking about whether we can provide our own parameters and run the simulation. Is that what you're asking, sir?
Yeah.
Yeah. So these simulators are prepared based on the some defined parameters or values. So we cannot change those. We cannot include or any other values from what we have already available in the platform. So the purpose of the simulation is to provide the basic concept behind the experimentation. So that your question is more like a research type of scenario. What will happen if the
Definitely, if it has to work for research students also, then it has to go this way only, na?
Right. For the research students, we need to explore more. We need to create additional features for this platform. So we are intended users of this virtual lab is UG and PG level students. So we are providing
one more inquiry is there. Can we have the faculty exchange program over here?
Okay.
Faculty exchange program.
Okay.
अनिश सर सर इसमें मैं थोड़ा सा एलिब्रेट करना चाहूंगा सर अभी जो वर्चुअल लैब की जा रही है सर मैं इस चीज में मैं थोड़ा सा इसमें क्लैरिफिकेशन देना चाहूंगा सर अभी जो वर्चुअल लैब प्रोवाइड की जा रही है ना वो बेस्ड ऑन स्टैंडर्ड मॉड्यूल्स दी जा रही है सर और हमारे स्टेट के लिए अगर हम नोडल सेंटर बना पाए जैसे कि सेक्रेटरी की तरफ से डायरेक्शन आई भी है तो उस नोडल सेंटर की तरफ से हम रिक्वेस्ट भेजेंगे।
मेरा बात ये है कि हमारा जो रेजिडेंट कैपेसिटी बिल्डिंग है वो हमारा पैरेलल ही चलना चाहिए एंड वी कैन डू इट। यदि आप मुझे एक एक्सपर्ट बनाते हो केमिस्ट्री के किसी एक्सपेरिमेंट का देन वी कैन गो फॉर द सिमुलेटेड टाइप ऑफ एक्सपेरिमेंट यदि वो फैकल्टी एक्सचेंज के थ्रू होता है तब। ये मैं कह रहा हूँ वी आर नॉट गोइंग टू
इसी में
कैपेसिटी बिल्डिंग हम बाद में करेंगे। ये मैं कह रहा हूँ
सर
यदि प्लेटफॉर्म खोल रहे हैं आप बोल रहे ये मैं कह रहा हूँ।
डॉक्टर चमन
अगर पहले मैम एक सेकंड बस मैं थोड़ा सा ये बोलना चाहूंगा कि एक बार पहले टेक्निकल सेशन कंप्लीट कर लें उसके बाद क्वेश्चन एंड आंसर का एक ही राउंड करेंगे क्योंकि अमृता का भी इसके बाद दूसरा ओरिएंटेशन सेशन दूसरे स्टेट के लिए शेड्यूल्ड है तो फर्स्ट हम टेक्निकल सेशन कंप्लीट कर लें तो सही रहेगा प्लीज। उसके बाद क्वेश्चन एंड आंसर एक शेड्यूल में रखा है आप देखेंगे तो उसमें हम डिस्कस कर लेंगे सारे जो भी डाउट्स हैं। सनीश सर प्लीज कंटिन्यू योर टेक्निकल सेशन एंड रिमेनिंग पार्ट ऑफ द प्रेजेंटेशन। Sanish sir.
Yeah, so at the end of the session, we will discuss more about your query. So now I'm just continue with the presentation. I'm just sharing my screen. Yeah, so I hope all of you can see the screen. So for accessing this virtual lab, you can simply type Amrita Virtual Lab. Okay, so I'm just simply searching Google Amrita Virtual Lab. So the first link you can see plab.amrita.edu. So you can click on the link for getting to the Amrita Virtual Labs homepage. So at the top there are several menus are available. Project, if you would like to know more about the project, you can go to the project menu over here. And also there is a notice under programs are listed over here. And there is a publication tab also available. So if you would like to know what are the recent publications using this virtual lab platform, how this is impacting on students' learning, and how it is impacting on institute, also all the results are available, articles are available in this part also. So we are inviting those who are interested to join with us for doing the collaborative research work. We are also inviting those faculty members also. Okay. So I'll just go to the home page and we can scroll down to see what are the disciplines are available. So as you can see, biotechnology and biomedical engineering, chemical science, physical science, and computer science, etc. So I will start with chemical science experiment. So I'm just click on the link, chemical science. So under this chemical science, you can see there are several labs are available: physical chemistry virtual lab, organic chemistry, inorganic chemistry, etc. So under each lab, you can see there are 8 to 10 experiments are available. So under this physical chemistry virtual lab, you can see spectrophotometry, cryoscopy, videoscopy, etc. So I will start with one of the experiments called spectrophotometry. So typically these apparatus are not commonly available in some of the institute, especially in rural area. So this spectrophotometry experiments provide the basic concept about that absorption and emission of radiation through particular material. And students can learn from this, understand the basic concept using the platform. So under this theory tab, you can see the objectives are very clearly mentioned: to measure the absorbance of the sample at different wavelength, and to find the unknown concentration of the sample, and also verify the Beer-Lambert law. So you can scroll down to see more details about the theoretical description. And at the bottom, you can see the of this particular experiment, spectrophotometer. So if you go to the next tab, which is procedure, so I'm just click on the procedure. So here, just like our traditional lab manual, students can see the what are the materials required for this particular experiment. So you can see we need spectrophotometer, cuvette, and blank solution, and these are the reagents that is available for doing this particular experimentation. And there are step-by-step instructions are provided, so students can refer this step-by-step instruction in order to complete the experimentation. And also you can see the observations and calculation. And there is a points to remember while performing in the real laboratory. So which is very crucial to perform the this type of points that students have to be very taken care of while performing the real experimentation. Okay. So there are some self-evaluation quizzes and available for this part from this platform. So sometimes students need to log in for accessing those experimentation. So I'm just providing a sample user ID. So once you log into the portal, you can access the simulation, self-evaluation, etc. So I'm just sharing the sample user ID for accessing this platform. So you can refer to the chat box for getting the user ID and password for accessing some of the labs from this platform. Okay. So you can see there are several questions are available. So you can see I'm just choosing some of the random answers, okay, and scroll down to the bottom and submit the answer using the submit button available at the bottom. So after submitting it, you can see what are the correct answers and wrong answers from this experimentation. So suppose the first answer is wrong, so I'm just changing the answer. So what is the value of absorption if the complete light is passing through the solution? Okay, so I'm just submitting the answer again. Okay, so you can see the first answer is correct. The green tick represents the correct answer, and the red cross representing the wrong answer. So that way students can verify, they can test their basic knowledge about the experimentation. So before coming to the simulation, I'm just explaining what are the other tabs contain. So there are assignments questions are available. So students can use this assignment question to perform more experiment using the platform. Most teachers can use this assignment to take a home assignment. We have also reference tabs available. Those who want to explore more about experimentation, they can use the reference tab. So we have a book, bibliography links are available. So they will get more insight or more information using the regarding the particular experimentation. And the final tab is the very important, the feedback tab. So I request all the for teachers as well as students to fill up the feedback after completing any of the experiment from this platform. So you can choose the type of experiment, whether it is simulator or measurement, etc. And there are simple questions are available. How do you rate the online performance, or did you face any problem? So you can mention all the details on this feedback tab. So after that, you can scroll down to the bottom and enter the captcha, then submit the feedback. So once it is submitted, our technical team will evaluate it, and if it is necessary, we will modify other content based on the feedback. Okay. So we'll come back to our main tab, which is called simulator. So under the simulator, you can see the setup for this particular experimentation. So if you are accessing mobile or tablet, you can see there is a 3-line button over here. This is called options for or controls for the particular experimentation. Okay. So if you are using desktop or tablet, you can maximize the view. Using the right top, there is a box icon over here. So you can click on the box icon to maximize the view. Okay. Yeah. So this is the apparatus called spectrophotometer, and at the top you can see there are several solutions are available. So one is the non-concentration, unknown concentration, blank cuvette, and the right hand side you can see there are several controls are available. Okay. So using this drop down box, you can choose any of the solution for our experimentation. So for example, I am choosing it as crystal violet. After that, I can change the concentration of the crystal violet. That is the non-concentration of the crystal violet solution. So I'm setting it at 0.001 m. After that, we need to start perform the experimentation. So all the procedures are available on the procedure tab. So if you find any difficulty to perform or perform using this simulator, please refer to the procedure tab. So you can easily follow the procedure and perform the experimentation. Okay. So initial step, we need to calibrate this spectrophotometer. So which is very crucial for getting the correct answer. So similar thing, we are also performing in this platform. So we are opening the lid of the spectrophotometer. So just click on the lid over here. It will open.
बेटा ठीक है वो जा रहा है कनाडा.
So we need to place the blank cuvette in the spectrophotometer. So just click on the blank cuvette. It will automatically place into the spectrophotometer. After that, so we need to close the lid. So just click on here to close the lid. Then there is a zero absorption or 100% transmission button over here. So you can click on here. So as you can see now it is absorption. So we just calibrated this spectrophotometer. So you can see now it is absorption spectrophotometer. Students have to take care to perform the traditional laboratory. So after calibrating, we can take off the blank cuvette, open the lid, and click on the blank cuvette, so it will automatically place over here. Then we need to place the non-concentration to identify the maximum absorption value. So I'm just click on the blank cuvette, it will click on the non-concentration, so it will place on the chamber in the spectrophotometer. So after that, closing the lid, then we need to increase the wavelength passing through the solution. That is custom. So increasing the wavelength. So here you can see 365 nanometer. So I'm just keep on increasing. So at 400 nanometer, we got the maximum absorption, which is 0.0426. And if you are increasing the wavelength again, you can see the absorption value is decreasing. And also if you are decreasing the wavelength, absorption value also decreasing. So students have to identify what is the maximum absorption wavelength through this particular solution. So using that value, they can calculate the unknown concentration. So I'll just replicate the same, how the typical students are performing in our lab scenario. So I'm just sharing my whole screen again. I'm just So I'm opening an Excel file for making the calculation. So we need to note down some of the reading. So we need to note the concentration. For example, C is the concentration, which is 0.001. And we need the length of the cuvette, L, which is 1 centimeter. So the length of the cuvette is associated with each spectrophotometer. So it is already mentioned in the equipment manual. So for this particular experiment, you can see the length of the cuvette is 1 centimeter, which is represented in this control panel. Okay. After that, we need to take the maximum absorption value. So I'm just not on the maximum absorption value, which is 0.0426. Okay. All right. So now we need to identify the unknown concentration using this particular experimentation. So for that, I'm just referring the procedure tab. So I'm just right click on the procedure, I'm opening in a new tab. Okay. So here we need to identify, we need to calculate the constant, which is called molar absorption coefficient using an equation E equal to A by Cl. So we're just substituting in the value over here. So consider E as our absorption coefficient. So I'm just taking the equation over here is equal to A by concentration into length of the cuvette and substituting the value over here. So absorption value is this one divided by concentration into length of the cuvette. Okay. So we got the molar absorption coefficient, which is 42.6. Okay. So now we need to identify what is the absorption for the unknown concentration. So again, come back to our simulator. Okay, so we are taking out this non-concentration. So just open the lid of the spectrophotometer and click on the non-concentration. So it will automatically place on this table. Then we need to place the unknown concentration. So I'm just click on the unknown concentration. So it will automatically place into the chamber of the spectrophotometer. Okay, so after that we are closing the lid of the spectrophotometer. So without changing any of the parameters or buttons in the spectrophotometer, students can directly note down the maximum absorption value, which is 1.9281. So I'm just note down the reading over here. Suppose A dash, that is the absorption value for the unknown concentration. So I'm just noting the reading 1.9281. Okay. So I can rearrange this equation to identify the concentration of the unknown concentration. So I'm just rearranging this by A is equal to A by epsilon into length of the cuvette. So I'm just substituting the value, that is A dash divided by molar absorption coefficient into length of the cuvette. Okay. So we got the concentration of the unknown solution concentration is 0.042526. So in this platform, there is a provision to just check our value whether it is correct or not. So value over here. So I'm just entering the value 0.04526. So after entering the value, you can click the submit button. Okay. So you can see this is a wrong answer. So you need to check it again. Yeah. So sometimes you make some mistakes with the calculation also. So this way students can verify whether their answer is correct or not. So once it is correct, you can see the correct answer over here. So that way students can verify whether their result is correct or wrong. So this is how you can perform this spectrophotometer experiment from this platform. So next one, I will move on to the chemical science simple experiments called EMF measurement. So I'm just going to the EMF measurement lab and directly go to the simulator tab, as we already discussed about other tabs. So I'm just click on the simulator. Okay. And also maximizing the view using the right top box icon over here. So I'm just click on here to maximize the view. So here you can see the temperature of the room temperature that we can change from 10 degrees Celsius to 100 degrees Celsius. So typically we cannot set the 100 degrees Celsius in our laboratory setup, but using this platform you can vary the temperature. And there are several selections for the cathode and anode electrode. So you can see there is a drop down menu over here. So there are a lot of options are available. So for example, zinc, cadmium, cobalt, tin, gold, etc. So just choose copper as our cathode electrode. So after selecting the copper as electrode, you can see the solution is changes to copper sulfate. So students will understood what is the solution they need to take for the particular selection of the electrode. So similarly, I'm changing the anode electrode. So I'm choosing it as zinc for this example. So after selecting the zinc as anode electrode, you can see the solution is changes to zinc sulfate, and immediately you can measure the potential difference across the two electrode, which is 1.1 volt. Okay. So there are several parameters that you can choose, like concentration and temperature. So students can understand what is the effect of changing concentration of the solution. For example, copper sulfate solution. So if you are increasing the concentration, you can see whether the voltage is increased or decreased. And also the teachers can prepare the question based on this parameter. So you can provide what is the potential difference or voltage drop across the two electrode for the particular selection of electrode, for example, gold or silver, and particular concentration value. So that way you can provide assignments to the students, and students will find it is very interesting for performing the experiments at their convenient time. Okay. So immediately you can that this platform will provide the potential drop. So this way students can understood they can under apparatus in our traditional laboratory. And right hand side, as I mentioned, there is a control panel for changing the parameters of the experimentation. So some of the experiments in physical science and chemistry also, there is an initial setup is very crucial for perform the experiment. So students have to perform the initial setup, then only they will get the correct answer or they can proceed with the experimentation. So we are imitating the same in this Persona platform as well. So for continue with this experimentation, students need to perform the initial setup using the initial setup button in the right hand side control panel. So just click on the initial setup. So in this particular experiment, we need to rotate the compass box to align the 90-90 line parallel to the circular coil. Okay, so there is a rotate compass box icon is slider is active. So you can click on here, and using the keyboard right arrow key, you can slowly rotate it, or else you can just touch and drag it, or using the mouse pointer also you can drag it, and you can slowly adjust it to get the 90-90 line horizontal to our view. Okay. So this is the basic initial adjustment for all the compass box related experiment in physical science experimentation. So after adjusting the 90-90 line parallel to the circular coil, we need to rotate the whole apparatus to make the needle coincide with the 0-0 line. So for that, there is a rotate apparatus slider is available in the right hand side. So you can slowly drag the rotate apparatus. So now we are rotating the whole apparatus to align the aluminum needle with the 0-0 line in the compass box. Okay. So I'm just aligning it and coinciding with the 0-0 line in this compass box. So as you can see, there is a parallax error we have purposefully implemented here, because in real laboratory students based on the direction of taking the reading, there is a parallax error students will get from this platform, from this readings. Okay, so the same situation we have imitated here also. So the both needle will not coincide in the same line in this particular experiment also. Okay. So after adjusting the initial setup, you can click the show normal button. After that, you can make the circuit diagram. So in the left top in the simulator window, you can see the circuit diagram over here. So all the components are arranged such a manner students can easily identify from this circuit diagram. So this E representing the cell over here. So near to the cell, there is an ammeter. So this is our ammeter, and the middle portion you can see the commutator over here. So let's see how to make the circuit diagram in this platform. So you can click one of the terminal and drag it like this, okay, and attach to the other terminal to make the connection wire. Similarly, I am connecting the negative terminal with key and key to the lower terminal of the rheostat and upper terminal of the rheostat with commutator. This is called commutator. Okay. Then commutator with our ammeter. So as you can see, the left hand circuit is complete. Now we need to connect the tangent galvanometer with this commutator. So similarly, you can take the connection wire from the commutator and attach it to the tangent galvanometer. And you need to take the second wire and attach it to the tangent galvanometer. So after making all the circuit, there is a insert key is available. So you can click on the insert key to insert the key. So as you click on the insert key, you can see the current is flowing through the circuit, and you can measure the current as well as the deflection angle from this compass box. So here there are a lot of parameters that students can change. For example, so if you are changing the rheostat value, it will reduce the current flowing through this tangent galvanometer, and it will also deflection also reduces based on the current flowing through this tangent galvanometer. So for measuring the reading from this compass box, there is a zoom compass button is available. So we can click on here to note the reading from the compass box. So here you can also adjust any of the parameters. It will immediately reflect on this compass box. For example, if you are changing the number of turns of the coil, you can see the deflection angle also changing based on the selection of any of the parameter. Okay. So in our traditional laboratory, the radius of the coil is almost fixed. So there is the one apparatus that radius may not be able to change. But using this platform, students can vary the radius of the coil and they can learn what is the effect of changing the radius in this magnetic field generation, the tangent galvanometer. Okay. Take the reading from this platform and they need to calculate it manually and verify whether their answer is correct or wrong using the show result button. Okay. So this is how you can perform the physical science experiments. Okay. So we'll quickly go through one more experiment from physical science. After that, we will move on to the biological stream. Okay. Yeah. So we are going to perform the electric circuit related experiment from this platform. So I'm choosing parallel LCR circuit for this example. Okay. So in this parallel LCR circuit, I'm directly go to the simulator tab. Okay. So as I mentioned, we have started this project on 2010. So at that time, we created experiments using flash content. So now none of the browsers are supporting the flash content. So if you are facing any difficulty, Adobe Flash Player is no longer supported or any error related to this loading the simulator, please refer to the procedure tab. So in the procedure tab, we have mentioned there is a link over here. Okay. And there is a flash plugin EOL header also over here. So we can open this link, flash plugin EOL, which are representing Adobe Flash Player end of life. Okay. So as I mentioned, Adobe no longer supported by the browsers. We have an alternate method to access the flash content. Okay. So first time you need to download the flash player into your system. After that, you can easily access the flash content from this platform. To download the flash content, we have provided 3 links over here. One is Windows, Macintosh, and Linux. So if you are using Windows system, you can click on the Windows link over here. So if you are using Mac system or Linux distribution, you can click on the corresponding link to download the flash player. So I'm using Windows system, so I'm just click on the Windows link over here. So if you download the flash content, you can click on the corresponding link to download it. So you download the flash content into my system. Okay. So after that, there is a step-by-step instructions provided. So first, we need to open the flash player, flash debugger. So this is the downloaded file.
You are not audible.
On here. Content into your desktop. Okay. So if you are using Linux or any other system, you need to download the corresponding flash player into your system. Okay, so after downloading it, I'm just opening the flash content. So this is the file we have just downloaded. So you can directly double click on it. So it will directly open the flash player. So you don't need to go through any.
Excuse me, you are not audible.
Yeah. Okay. So I will just repeat it again.
You are audible now.
Okay. So yeah. So this typical situations can happen based on the internet connectivity issue. Okay, so I'm just repeating it. Once you download the flash player, you can go to the download location and double click to open the flash player. So this is the flash player I have opened in my desktop. Okay. Now I am going to the procedure tab. So in this procedure tab, we have a link over here. So I'm just copy the link from the procedure tab. Okay, select the link and copy it. And I'm opening the flash player. Then go to the file and open link. And this pop-up box, we have to paste the link and click OK button to load the flash content. Okay. So as you can see, now we have successfully loaded the AC simulator in our desktop. So the right hand side, there are several components that you can see. And the left hand side, there is a white space where you can make circuit diagram and perform the experiment. So I'm just click and drag the component. So as you can see, very easily you can make any circuit, AC circuit using this passive component. So just click and drag it. So I'm using the capacitor. And this is our AC power source. So I'm just click and drag the power source. And we need a mechanical switch. So I'm using the mechanical switch. And there is an ammeter. Okay. So now we need to make the circuit diagram. So this is the wire for making the circuit diagram. So just you can click and drag as many number of wires necessary for making the circuit diagram. So we are creating a parallel LCR circuit. Okay. So for connecting this wire with the component, you have to click one end of the wire and drag it and attach it to the terminal of the component. Okay. So once your connection is perfect, you can see the gray color appear in the junction. That represents our connection is perfect. And if you are moving the component, you can see the wire is also moving along with the component. So that means our connection is perfect. So sometimes students make mistake like they are placing the wire over the component like this. So this is look like connected, but when you are moving the component, the wire is on the same place. That means your connection is not perfect. So when you are making any circuit, make sure that your connection is perfect. Otherwise, you will get the wrong answer. So you can drag to check whether your connection is perfect or not. Okay. So similarly, I'm just commenting the circuit diagram, connecting the left hand side together. Sorry, the right hand side together. Okay. So I'm connecting the left hand side of the circuit diagram and connecting the wire with the resistor, and second one with the inductor and connect capacitor. Okay. So now we have made one mistake over here. We have connected with the positive terminal of the capacitor. So in that case, there is a delete button and split button also available. So you can click here and delete the wire using the delete button available at the bottom. Okay. So if you would like to split the connection, there is a split button also available. So similarly, you can split the connection using the button. Okay. So now I'm connecting the left hand side of the circuit diagram, and we are connecting the circuit with our power source and connecting the power source with mechanical key and connecting the key with our ammeter. Now I'm closing the circuit. Parameters of each of the components. So for second parameters, you click the component in the parameter. So one thing that you can I'm changing the inductance value and capacitance value. So if I click on the white space over here and capacitance value, so you can click on the white space over the options that you can access. So there is a show value button available. So you can click on here to see what are the values for each of the parameters. And also there is a lifelike and schematic representation is available. So some faculty members, students would like to see the schematic representation. So for them, it is easy schematic using the radio button. So when you are clicking the schematic, you can see all the components are changed to schematic representation. So I am using the lifelike view in the more appeal of the apparatus components. So as it's an AC circuit, I am setting the frequency value 100 and RMS voltage, which is 50 volt. Okay. After that, I'm using an ammeter, so voltmeter, to measure the voltage across the component. So for this particular experiment, students need to identify the impedance frequency. So they need to change the frequency of the AC source and they need to identify the impedance frequency of the circuit. So I'm just switch on the AC power source. So the green light representing our power source is switched on. Now we need to switch on close the circuit using the mechanical switch over here. So you can double click on it to close the circuit. So as you can see, our voltage is 50 volt across the component and corresponding current to the circuit is 25.13 ampere. So there is a non-contact ammeter also available. So you can place anywhere in the circuit to measure the current flow to the particular branch of the circuit. So suppose if you are decreasing the inductance value, the students may not be able to imagine what will happen in our traditional situation. So let's see if I am reducing the inductance value. So as you can see, the maximum current will flow to this branch and that also damage our apparatus. So as you can see, our power source is just burned out. That means there is a short circuit happened in our circuit diagram. So that way students can make trial and error method to understand the AC circuit simulation concept, and they can easily take the measurements from this platform. Okay, so this is how you can perform the AC circuit simulation or any flash related experiment from this platform. So I'll just repeat it again. So if you find any difficulty for accessing the flash content or any error associated with the flash player, you can go to the procedure tab, refer the procedure tab, and there is a link header over here. So you can open the header. Then you need to download the Flash player for the Windows, Mac, or Linux based on your operating system. So after that, so once you download it, you can copy the link from the procedure tab, and you can open the Flash player. And here you can need to go to the file menu, then open, and in this window you need to paste the link and click OK button to load the Flash content. Okay. So as I have already downloaded this Flash player, next time I can directly copy the link and paste into this window to open the Flash content. So currently we are converting this Flash into HTML5, which is platform independent. So still the conversion is over. We request you to use this indirect method for accessing the Flash content. Okay. Yeah, so this is how you can perform the physics and chemistry laboratory from this platform. So I hope all of you understood the basic setup or parameters that from this platform. Now I would like to request Nijin to perform some of the biotechnology virtual labs for the teacher from Uttarakhand University. Over to you, Nijin. Yeah. Not audible. Your voice is not audible. Nijin, can you? So I think there is some technical issue with Mrs. Nijin. So all right. So I will just yeah, I will present some of the experiments from biotechnology labs as well, because there are some technical issue. So I'm just sharing the screen again. So we go to the home page. Okay. So from the home page, I'm opening the biotechnology and biomedical engineering. Okay, from link we are opening the biotechnology. So there are a lot of labs are available under biotechnology and biomedical. As you can see, biosignal processing and analysis, bioinformatics, neurophysiology virtual lab, neurosimulation, biochemistry virtual lab 2. So this 1 and 2 representing the UG and PG level laboratory from this biotechnology. And population ecology, immunization virtual lab, immunology virtual lab 2, etc. Okay, so I will going to explain one of the experiments from immunology virtual lab. So we'll just see how we can perform the biotechnology experiment. So I'm using the blood grouping experiment, which is very common in our biotechnology laboratory. So blood grouping is the most common experiment, and also all the students should know how the typical blood grouping are doing in our laboratory setup or any of the hospitals, etc. So this is an interactive animation. So as I mentioned, there is a fail to detect the Flash player. So I'm going to the procedure tab and copy the link from the procedure tab. Okay, and open the Flash player and go to the file, open, and paste the link over here and click OK button. So as you can see, this is a blood grouping experiment from biotechnology. So in this, there are several controls are available. So center, you can see the start button. At the right top, you can see the pause, next, and forward button is available. Okay, so I'm just click on the start button. Okay. So in this animation, there is no audio is available. So we have provided subtitle at the bottom of the animation. Okay. So all the procedures are very clearly described in this animation. So as you can see, take out the alcohol pad from this packet. So we are taking the alcohol pad. So after taking, all the waste should be carefully deposited in a beaker. After that, we are applying the alcohol pad at the site where we are collecting the blood sample. Then again we are placing into the beaker. Then we are taking the lancet cover and prepare the fingertip for blood collection. So as you can see how to handle this apparatus and how to pick the fingertip, all the steps are very clearly mentioned in this animation. Okay. So the fingertip, we are collecting the blood sample to identify the blood group of the experimentation. So after taking that, we need to carefully deposit in the biohazardous chamber because that containing blood, which is very prone for bacterial growth or virus growth, etc. Then we are collecting 3 drops of blood in a glass plate and we are placing on the table. Okay. So after that, we are carefully cover the tip of the finger using the cotton ball to stop the flow of the blood. Okay. So as I mentioned, each and every step are very clearly designed from this platform. So students will not miss any of the important steps in the practical laboratory setup. So now it is an interactive animation. So you can see I can control the hand using my mouse pointer. So we need to add this antigen A, monoclonal A, B and D into this 3 drop of blood. For that, we can click and drag the okay and release the mouse button on top of the first drop of blood. Similarly, I am taking the second and monoclonal B. We just click and drag it and release the mouse button on top of the second drop of blood. And similarly, we are adding monoclonal D into the third drop of blood. Okay. So after adding this monoclonal A, B and D, we need to mix it very carefully. For that, we need to use the toothpick. Okay. So I'm just taking the toothpick and mixing the blood sample. Okay. So if you are using the same toothpick for mixing the another blood sample, there is an error message will pop up. So we should not mix the same toothpick using for different blood sample. So that is also very important step students have to very carefully perform in their laboratory. Okay. Similarly, I am mixing the third drop of blood. Okay. So once it is completed, there is a continue button will appear at the right hand side of the window. So you can click on the continue button to see what is the blood grouping of the particular blood sample. So now you can see there are 3 drops of blood, none of them are coagulated. So you can connect map with our right hand side chart over here and we can identify the blood group of the particular sample. So now it is O negative. So as you can very clearly connect that none of the blood samples are coagulated. So we can click over here any of the answer. So it will show whether it is correct or wrong. So I'm just click on the O negative over here. See? So you can see this is correct. So our answer is correct. So when the students are performing this experiment multiple times, they will get a random answer. So that way students can understand the basic concept behind the experimentation and also they will get the they will understand all the procedure behind the experimentation. And if the students find it is difficult to follow the procedure, they can use the simulation animation over here and they can read the subtitle and after that they can perform the continuity animation of the particular experimentation. Okay. Yeah, so this is how you can perform the biotechnology experiments and I hope all of you understood how to access this flash or animation from this particular virtual lab platform. Okay. So I'll also introduce the main website. So as I mentioned, vlab.co.in, that is the main website for the Ministry of Education Virtual Laboratory website. So from this, we can access all the laboratories developed by all the premier institute. So you can scroll down to see what are the participating institute and you can see the broad areas of virtual lab here also. Okay, so if you go to the biotechnology and biomedical, you can see there are other labs also available, that is biomedical signal that is created by IIT Roorkee. Similarly, you can see IIT Delhi also have one lab. Okay, biocharacter, modeling and simulation lab, etc. So from this homepage also you can access any of the labs developed by IITs and other prominent institute. Okay. So this is, I hope all of you understood how to access this virtual lab from the platform. And I request all of the faculty members as well as students to go and explore from this platform. And while doing the experiment, initially you will find some difficulty to familiarize with some of the parameters or controls. So once you're familiarized with the platform, very easily you can perform any of the real laboratory. So with that, we will concluding our online workshop this virtual lab. So, Higher Education Department, Higher Education Uttarakhand, Global's principal for patiently listen to this online virtual lab session. So we have a few minute time for any query question and answer session. So over to you for this.
Sir, I have a quick question. Good morning.
Yeah, please continue. Your voice is breaking. Maybe you can check your microphone again.
Excuse me, this is Sanjay. I
Hello, sir.
just want to know one thing.
You have shared a email ID with us for logging in. So can you share it with us again? So can you share the email ID for login? Hello? Hello?
Yes,
Hello,
yes,
sir?
yes. So we will provide unique user ID and password for all the faculty members upon getting the list of faculty members. So that Dr. Shaman Kumar is working on it, I hope. So once we get the list, we will provide the user ID and password for each faculty members separately.
Sinesh, I wanted to know one thing that you told that I can go for this simulated experiment with my students also as the test model. Isn't it?
Yes, yes, you can.
Provided that comes within the purview of your data bank.
So could you please repeat that question
again? We can go for the test of experimental test online with the students on the virtual lab through the data models that is with you. That's
so
all
currently
I'm asking for.
Okay, so currently we cannot add any additional parameters for the.
I'm talking about the parameters you have already allowed for, na? Because some graphical results, I am a student of chemistry, some graphical results can already be done, can easily be done by the students once the simulated part is there.
So from the simulator part, they can take the readings and the calculations and all the part that they need to do it manually.
Yeah. No, manually, I just wanted to know if we are going for this online virtual lab, then there has to be some mechanism, some device to test them online also. And that will be the real capacity building of the students and the teachers also.
Okay, so what I understood is how to access the students are performing these experiments online.
No.
Is it correct?
That is not the continuous evaluation type thing. I just gave one experiment with the parameters, with the revised parameters, and they will come with the result. Yeah, this is showing this result.
Right.
That can be done, no?
Yeah, that can be done. That can be done.
That's what I was asking for. A second, is this because some UG program and some PG program, the practicals, UG practicals are of 6 hours and this 8 hours in PG practicals are 8 hours. So is this UGC has already approved this model simulated experiments through virtual labs?
Yeah. So what? Yes. So these ICT tools should be a part of this curriculum. It's already implemented. I think it's already a rule for implementing this ICT enabled platform.
University Board of Studies will have to work on this, no?
That part I need to discuss with our higher authorities because this is Ministry of Education's project for this is need to be implemented all the institute in India.
Yeah. Thank you so much.
So
nice presentation. Thank you.
Hello.
Nice presentation.
Yeah. Hello,
you
Sanis.
worked really hard. Thank you.
Hello, Sanis.
Yes, sir. Please continue.
I'm Dr. Rakesh.
Hi, sir.
Okay.
Please continue.
Thank you very much for your good presentation regarding the virtual lab. I would like to give some suggestion regarding the Uttarakhand is basically concerned with the basic education related with the biology, zoology and botany. That is not included in your program. So I would request you to kindly include the zoology and botany basic sciences, because that is more than 95% institution and the colleges are concerned with this one. This is a good thing that you have included the biotechnology, but we need to add the zoology and botany basics. So
Right. So I understood that.
yeah.
So I'm from science
some
background, so I
biochemical
don't.
and physiology experiment also.
Biochemical.
So I request you to go through this platform, biotechnology. So some of the experiments that definitely you can find out.
I can go. I know that biotechnology covered few things, not all the things. Actually, basic sciences is something different.
Don't you have the life sciences experiments? Orthodox life sciences experiments?
Yeah, so there is another platform called
listen, Dr. Sunny, please listen. Because see, for example, the taxonomy, like this animal diversity, like the ecological experiments. So these kind of things that the applied geology, this is the cell biology, instrumentation, that it may be included in the biotechnology program. But ecological experiment, endocrinology slide, this is slides, and that they say animal diversity slides of the different organs. So these have included. Similarly, some plants anatomy, plant physiology, plant taxonomy, how to identify the plants, how to identify the specimen. So these kind of things that you have to include in this your program, and I think it will be better for us because Uttarakhand is basically concerned with the basic education, and only just a few institutions that they have the biotechnology program. Rest of the institutions they have the basic sciences, the zoology and botany. So this is my request to you, kindly include this kind of the.
Yeah, thank you for giving that valuable input. So I understood that now currently that none of the institute are allowed to use any animal dissection in your process. So include we have included any of included some of the experiments in this platform.
Also there's some animal diversity and all that.
We will consider for the future development of this platform as well. Thank you.
Thank you very much. Thank you for.
Hello, sir. Am I audible now?
Yeah, I can hear you, ma'am. Please.
Congratulations for such a wonderful presentation, and I am sure that your information will be very helpful for the students who are on the far-flung areas of hills. One more thing, I was curious whether if many students are using the same login which you will be providing us, and the username and the password. So how many students can at the same time use the same ID?
So as it is an online laboratory, there is no limitation for accessing this number of participants. So based on the server capacity, I think we have conducted around almost more than 10,000 logins at a time. So it is not an issue for accessing multiple.
Wonderful, sir. Thank you.
In this virtual lab workshop, this was the very first orientation program. In future, we are expecting Sanisha and Krishna ma'am that we would invite you for the offline workshop, and that was from the responses collected from the audience. We can say that this was a very successful by you, Sanisha. And for thank note again, I would like to invite our assistant director, sir, Dr. Govind Patak, sir, from the Directorate of Higher Education, Uttarakhand, Halwani. So, sir, please present here. Sir, please join us for the thank note.
Hello, am I audible?
Yes, sir. Yes, sir.
Thank you very much, Dr. Chavan Kumar, Nodal Officer, Digital Initiative. This is a wonderful presentation and wonderful things which Dr. Srees has tell us about, and I congratulate the Amrita Vidya Peetham Kerala जिन्होंने उत्तराखंड उच्च शिक्षा विभाग के साथ एक MOU साइन किया है रिगार्डिंग वर्चुअल लैब हमारे पर्वतीय रूरल एरियाज में को इस्टेब्लिश करना ऑनलाइन के माध्यम से, और प्लस हर एक छात्र छात्राओं को इसका बेनिफिट मिलेगा. सो आई थैंक्स द होल टीम ऑफ अमृता विद्यापीठम फॉर देयर नाइस प्रेजेंटेशन एंड सपोर्ट फॉर अस. Or I would also like to thanks to our secretary sir, Sri Sailesh Gogori sir, and additional secretary Sri Prashant Arya sir, जिनके विजन से ये डिजिटल इनिशिएटिव के कार्य किए जा रहे हैं. And I will also thanks to our director sir, Professor C.D. Sutha sir, and none other than our nodal officer, digital initiative, Dr. Chaman Kumar sir, Dr. Sailen Singh, and Dr. Deepak Pandey, my colleague, and all the faculty members and students and principals जिन्होंने इस वर्कशॉप में पार्टिसिपेशन करके और जिन्होंने अपना बहुमूल्य समय दिया इस वर्कशॉप को सक्सेस बनाने के लिए, मैं उन सभी का तहे दिल से, हृदय से धन्यवाद देना चाहता हूं सर. ऑल द प्रिंसिपल, आई सैल्यूट यू कि आपने क्वेश्चन एंड आंसर सेशन भी एक यहाँ पे चला जिसमें प्रोफेसर संजय सर, राकेश सर, इन्होंने बड़ी एक सही बात कही कि वी आर नॉट बॉदरिंग अबाउट द हाई मींस बायोटेक एंड ऑल दिस थिंग्स. वी आर परसुइंग, हम स्टूडेंट्स को यहाँ पे एक बेसिक हम चीजें भी करा रहे हैं, बॉटनी, जूलॉजी या और भी हमारी आर्ट्स की भी लैब्स हैं, ज्योग्राफी लैब्स है, हमारी एजुकेशन लैब्स हैं और म्यूजिक के लैब्स वगैरह. तो मुझे उम्मीद है कि आने वाले टाइम में हम लोग आपसे मिलके जैसे कि हमारा एमओयू साइन हुआ है अमृता विद्यापीठम से, केरला से, और हम लोग अपने हिसाब से अपने सिलेबस के अकॉर्डिंग, सिलेबाई के अकॉर्डिंग ये कोर्स डिजाइन करेंगे, प्रैक्टिकल्स डिजाइन करेंगे. एंड आप जब ऑफलाइन वर्कशॉप करेंगे तो उसमें हमें इससे काफी बेनिफिट मिलेगा एज रिक्वायरमेंट बाय द कॉलेजेस के हिसाब से. सो थैंक यू वेरी मच ऑल ऑफ यू जिन्होंने हमें ज्वाइन किया इस वेबएक्स मीटिंग में. थैंक यू ऑल द टेक्निकल टीम जो हमारे साथ जुड़े रहे, एंड थैंक यू वेरी मच द नोडल ऑफिसर. थैंक यू सर, थैंक यू वेरी मच.
Thank you, sir. Thank you, sir. Thank you. So I have a small request before winding up. If possible, can you please turn off all of your camera? You can take a small snap before winding up. So those who are possible. चलो आगे देखा जाए. हाँ, फोटो देखिए हमने क्या ले रही है गुरुजी. फोटो